All right, chemistry students, I'm going to go through this little super absorbent polymer lab. It's the Orbeez lab. Now, this is traditionally something I'd have you guys do in class. We'd do it in the first week or so of class. You'd learn about how to use significant digits and measure things appropriately on the scale and calculate things with appropriate precision. And now you just get a video of it. So hopefully this video works. I'm going to try my best. It's going to be a little clunky, but again, this is the best we've got. You can see I'm doing this at my house. The lighting's a little dim. This is just my kitchen, so bear with me here. So I've got my ruler, right? This is my printable ruler. I've made a little crease because you guys can see what I'm going to do. I'm going to be measuring an average bead diameter here in a second. Measuring the diameter of something like that would be pretty tough with a ruler. So if you guys remember, this ruler measures down to the 10th of a centimeter. It goes 1 decimal place past a centimeter. That's the markings, and then your eyeball can go 1 past that. So I actually can get centimeters and then point down to the hundredths of a centimeter, okay? So let me line these up. I'll count out the beads here in a second. Okay, I'm gonna have you guys do the analysis. So I'm just gonna read off the data basically. Once you guys have the data, you're going to be answering questions in the lab assignment on Canvas. All right, so here we go. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. There's 20 Orbeez, and they are currently sitting just past 5.5. So I'm going to say, and you guys will have to listen because I don't want to write these down. This is 5.52 centimeters. Okay, with that you can calculate the average bead diameter. Now, I'm going to measure their mass on a scale. This will also help because I am going to be putting some of these in water. Okay, so let's just get a mass of these. So I can tare the scale. This is in grams. This scale goes down to the hundredths of a gram. Let's see if 20 Orbeez register. Hopefully I don't spill any. Oops, there they go. Right after I say that. Let me put these in. Okay, now you can see that those 20 don't have very much mass. I actually have only, if you guys count it, only 2 sig figs. So if I was to divide by 20 right now, the average mass would only have 2 sig figs. So what I'm going to do for their mass, I'm actually going to add some more Orbeez until I get up to over a gram. That'll give me 3 digits of precision. So 21, 22, 23, 24, 25. 26, 27, 28, 29, 30, 31, 32. Sorry, we only have to do this once. 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, almost there. 56, 57, 58, 59, 60, 61, 62, 63. Okay, now 63 Orbeez have a mass of 1.12 grams. So that has 3 digits of precision. Now, the only other way I could have done that quicker is if I had a more precise scale that went down to the thousandths of a gram or the milligram. Then I wouldn't have had to keep adding so many Orbeez. I could have just gotten 3 sig figs with my original 20. So I think that was 63 Orbeez, 1.12 grams. That'll help you with your average mass, okay? Your average mass should also have 3 significant digits. And this is in grams again. Okay, now you notice that there was some fluctuation. One couple things can happen. The scale's not great. Scales do take a little time to warm up because there's some electronics in there. These beads are hygroscopic. They're grabbing water from the air already, so they might be getting heavier as we're standing here. And then the other thing is that last digit is actually an estimated digit by the scale, so it's going to fluctuate. So 1.12 versus 1.14, it's not going to give you a huge difference. Actually, you guys should try that when you're calculating your average, try those two. It's not going to mess with the average that much, okay, that small fluctuation. So a lot of times on a scale, the last digit is referred to as an estimated digit. These two in the front will probably be rock solid. There you go, you see it changing. Okay, so there's the mass. Let me take these now. We're going to try some things. I'm going to put approximately 20 Orbeez. Okay, got this. I'm gonna go get some water. Ignore my dirty dishes. All right, let me label this. So this is just tap water. We'll come back to that vial tomorrow. Set that there. Okay, next one so that you guys can see. Let's test some of these. I'll do the same kind of thing. Let's get the average diameter here. It won't take very many this time. There are some manufacturing differences, especially among colors. You can see that this one was rather large compared to the rest. But let's say this one goes to, let's give it one more. This one looks kind of nice. Line this up. So 6 large Orbeez when calculating their average diameter. 6 large Orbeez have a measurement of, we're going to say 6.50. It's right on the line. 6.50, which is 3 sig figs, 6.50 centimeters for 6 Orbeez. They have a mass of 5 grams. Oops, and I'm not sure if I hit the tear button. Yep, I did. So 6 Orbeez weigh, there's a little difference, 4.96. 6 Orbeez, 4.96. These are the large ones. I know that these get rather large, so I'm going to just put 6 of them. Okay, 6 of them inside, and let's see. Yeah, let's give them some water. Okay, we know that that's tap water. Okay, and this is just the fun stuff. We're just gonna see how big they get. I'm gonna have you guys calculate some percent changes. Let's see. I do want to also do some tests. So I have some sodium chloride, just table salt. I'm gonna make a small solution of table salt. So, and then we're gonna put some Orbeez in it, just so you guys can see what happens. And how absorbent they are when they're in salt water. So let me grab another cup. Oh, that's a little heavy. This is just to hold the flask in place while I measure out some salt. Now, I'm gonna make about a 10% salt solution, 10% by mass. So I'm gonna have roughly 45 milliliters of water, or of solution, when I fill this in. Water weighs about 1 gram for every milliliter. So if I was to fill up water to the 45, it would be roughly 45 grams of water. I'm gonna then put in about 4 to 5 grams of salt. And let's see if I can do this. I'll get a spoon. I forgot who this is. What's the girl Elmo? Or girl Muppet? Chloe? Chloe? This is Linus's. All right, so let's see if I can get 4.5 tear. Doesn't really matter. I'm just gonna shoot for this. You guys are gonna calculate it. So I have 4.32 grams of salt. Right, I hit tear, so I removed the weight of the plastic in this. So that's we'll call it 4.32 grams of salt. Then I'm gonna fill it up with some water. And a total mass of 49.79. Okay, so I know the total mass and I knew how much salt. So if I divide the salt mass by the total mass, that'll give me a percent. Again, it's fluctuating a little, 49.81. Okay, so let me give it a little shake. It's a little bit less than 10% salt. All right, we're gonna say the salt's dissolved. I'm gonna just throw in 20 or so. These are just for comparison, and I'll label it. This is roughly 10% salt water. Okay, that can go back there. Okay, now that'll be good. We're not going to do any other large ones in water. We're going to do one more test. I've never done this before, but I want you guys to, hopefully this will be impressive. I'm going to soak these in isopropyl alcohol. Now this is rubbing alcohol, 91% rubbing alcohol, so it should be fairly flammable. So we're going to see if what happens to an Orbeez later tomorrow once it's soaked up some alcohol. The other 9%, if you're wondering, right, because it's got to get to 100%, the other 9% is water. So anything above 50%, that's known as 100 proof. That should be flammable. This is 91% is highly flammable. You get one more cup. And then let's remember, I'm going to put reddish, pinkish ones. We're not going to measure the mass of these. This is just for fun. We'll know that the reddish, pinkish ones are the ones that I'm going to light on fire. I should probably cover this one too, because the alcohol will evaporate pretty quickly. Although this is a lot of rubbing alcohol, so it probably won't evaporate. And I know that these absorb a lot, so I'm going to fill this up about halfway. If they look like they're absorbing it all, I will add more. Okay, so I'm gonna cover those. We're gonna let them sit. We're gonna come back and analyze. Between now and then, you should be going through the lab calculations. You can calculate the average diameter, the average masses. I'll have a list of all this for you. Average diameter, average mass. Once you know the diameter, you can get the volume. Once you know the volume of the bead and the mass, you can calculate the density. And if you guys notice, take a look, all those in the water, salt water, isopropyl alcohol, but especially the water, they sunk. And so that tells us that their density should be greater than that of water. Okay, so when you guys calculate the density of your Orbeez, you should get a value that's bigger than 1. That would be a good reality check. In chemistry, we always talk about, in labs and things, we always talk about making reality checks so that you know you're doing something right. If you get some crazy answer that tells you that these things have a density of 0.0001 and they're sinking, then you know you did something wrong. Because again, water's density is 1.0 grams per cubic centimeter. Hopefully that gets you started. Again, be patient with this lab. I know it's not the best. Format, but we're gonna go with it and we're gonna learn something. So I'll learn how to work with this GoPro better. So thanks. Talk to you later.